Oops, sorry about that. Here we go. Now, ladies and gentlemen, welcome to our 8.3 inverse functions notes. Start with 8.3 here. This might be a two-parter video. We'll see. We'll see kind of how it shakes out time-wise and whatnot. I only got 15 minutes to go, and I got quite a lot to cover in this video. So I might just do this one slide first, and then I might cover the next slide, a couple slides in the next one. Okay, so the first thing that we're going to be doing with is domain restrictions, okay? So 8.3, the first part deals mostly with domain restrictions. Now, in the past, when we think of domain, we think of, our negative infinity to infinity, all right? Kind of written out like this, all right? And again, just one thing to remember, that domain is all your possible x values, all right? All your possible x values for your domain, all right? So domain is basically possible x values, all right? That's basically what the domain is. And before, we didn't really have any limit on x values that we could plug in, because x values are numbers that we can plug in. But now that we're getting, say, like numbers like x's in the bottom of fractions like this, or underneath square roots right like this, now we have a limit of what we can plug in. So we have basically kind of two rules that we have for kind of plugging in x's for like functions. So the first rule is the bottom of a fraction can't be zero. So again, this is something that we've always dealt with. We can't have that. All right, can't have a zero on the bottom of a fraction. I can have a zero on the top of the fraction, but not on the bottom. The other rule is underneath the square root, I cannot have a negative. Now, technically, in the past, yes, we've dealt with i's and negative numbers underneath square roots, but for this instance, I do not, and for basically this chapter, I do not want to deal with any i's or any square roots, negatives underneath square root functions. All right? All right, so what I'm looking for, again, I'm looking for two things here. I'm looking for either x on bottom of fraction, just like this one, or I'm looking for x under square root. Those are the two things I'm looking for, all right? If I don't have those two things, then essentially my domain is still negative infinity to infinity, all right, which is basically unlimited. So again, I'm looking for these two things here, all right? So just give myself enough room. I'm going to erase this stuff here, and I'm going to go, and then we're going to go and start here. So what I'd go ahead and do, so for this first problem, there we go. For this first problem, I got negative 4 over x minus 5 minus 1, and I want to find the domain of that. And as I just previously stated, I see that I have an x on the bottom of my fraction here. So what I do is I take this whole x minus 5 right here, and I just set it equal to 0, and I solve. If you solve, you get 5, all right, x equals 5. I'm not going to write out x equals 5, it's just I'm just going to write it out. I'm just going to write out 5. Now pretend like we had a number line, all right? I'm going to do numbers that are smaller than 4, and I'm going to do numbers that are bigger than 4, all right? So 6. So the minus sign means small, this means big, all right? And basically what I'm looking at is seeing, can I plug these numbers in here, all right? And 4, and, all right. So if I start with 5, if I plug in 5 for x, well, I'm going to get negative 4 over 0. And again, just because, like this rule up here, I can't have that. So what that means is I cannot plug in a 5. What about 4? All right, I'm going to try and plug in a 4 here. I'm going to erase this. If I plug in a 4, I have 4 minus 5 over negative 4. That just gets me negative 4 over negative 1, which is just 4. So that's okay. I can plug in 4. 4 is good to plug in. And then what about 6? Can I plug in 6? Well, again, erasing this here. And if you need to slow it down, you can. If I plug in 6, negative 4 over, and then plug in 6 for x, 6 minus 5, you get negative 4 over 1, which is just negative 4. So that works as well. So what that tells me is I can plug in numbers that are smaller than 4 and bigger than 4. No, smaller than 5, but bigger than 5, but not 5 itself. So the way that we would write that, there's a couple of ways we could write that. One way we could write it is kind of like with the infinities up here. So the way I would write that is in a parenthesis, negative infinity, leading up to 5. This basically represents all my numbers that are smaller than 5. So I'm starting all the way small, going up, 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 till I reach, 1, 2, 3, 4, and then I don't hit 5. So I'm going to put a parenthesis around it, and then I'm going to put another parenthesis, and I'm going to copy the 5 down, and then I'm just going to put another parenthesis, infinity there. This basically represents all my numbers going up to infinity. So negative infinity to 5, skip 5, that's basically what this parenthesis 5 right here means, and then I go up to infinity, all right? So that's one way I could write my domain. Another way I could write it out is all real numbers, and a comma, oh, darn it, comma, x with an equal sign slash does not equal 5. All real numbers, x cannot equal 5, okay? All right, so, and that's how I write out, so those are a couple ways of writing out a domain, all right? So if you want to pause the video, write down any more notes you can, or need to rewind it, you can do that. I'm going to pause real quick and erase. All right, going back to this one here, so now I'm going on to g of x here, all right? So I have g of x, x minus 3 plus 8. Again, I'm looking for an x underneath the square root or underneath a fraction, and I just look, I have an x underneath the square root here. So just like I did with the x minus 5 over here, I'm going to take this x minus 3, minus 3, excuse me, and I'm basically going to set it equal to 0. Solve that out, I get myself x equals, well, 3, okay? So I'm going to get myself x equals 3. So now with that, now that it's the same thing I did over here. So I set it equals 0, I get my number, and then what I do is I kind of put my number on a little bit of a number line. So I do 3, and then a number that's bigger than 3, a number that's smaller. So 3, 2, and then 4, okay? Now remember, I'm dealing with a square root here. So my cardinal rule is I can't have a negative underneath that square root. So that's what I'm looking for, is whether or not I have a negative. If I start with 3, if I plug in 3, I get, well, square root of 3 minus 3. And that's equal to square root of 0, which is 0, which works. I can take the square root of 0. So 3 is okay. I can plug in 3. If I take 2 minus 3, I get the square root of negative 1. Now again, that's a negative. I cannot have that. So what that means is that I cannot plug in negative 2, or plug in 2, and therefore I can't plug in any numbers that are less than 2, all right? And then from there, I go 4 minus 3, that just gets me square root of 1, which is 1. That's acceptable. I can plug that in. So what this tells me here is that I can plug in numbers that are I can't plug any numbers in that are less than 3. I can plug in 3 itself, and 4 and numbers that are bigger than 3, excuse me. I can plug in 3 and numbers that are bigger than 3, but I can't plug in 3 itself. So a couple ways we could write that out. I'll write that over here. So if we're thinking in terms of infinities, interval notation. Well, I start at 3, and I can go numbers that are bigger than 3. So the way that I would do that is, if I'm going all the way this way, numbers that keep going larger and larger in the positive, I'm eventually going to reach positive infinity. And again, I start at 3. And then I can plug that 3 in, which means a bracket sign there. All right. Again, the bracket means I can plug it in. All right. That bracket sign with the 3 there. Now, with the other way that we could write it out, we could write it as an inequality. So let's say x is the number that I'm going to plug in. This is the number I'm plugging in. Plug in. Can I plug in 3? Yes, so can I plug in numbers that are bigger than 3? Yes, I can. So it's going to be x is greater than 3. But again, I can also plug in 3 itself, so it's also going to be x is greater than or equal to 3. All right, so again, there's 2 different ways that you can write it out here. All right. Again, if you need to pause, you can go ahead and do that. I'm going to pause and erase real quick here. All right, so going on to b of x here, this one right here. Again, 2 things. Do I have an x underneath on the bottom of a fraction or underneath the square root? I have an x underneath the square root. So what I'm going to do is I'm going to take 2x plus 1. I take the whole thing, set it equal to 0. If I solve, I'm going to get 2x equals negative 1. I'm going to get x equals negative 1. Negative 1 over 2, excuse me. Now what do I do with this? I'm going to do this over here, actually. Start with negative 1 over 2. I want a number that's bigger than 1 over 2, negative 1 over 2, and a number that's smaller than negative 1 over 2. A number that's bigger is 0, and a number that's smaller is negative 1. All right? And from this, I want to see which of these numbers I can plug in. If I start with a negative 1/2, all right? Let's see. So 2 times 1/2 negative plus 1, that gets me 2 times negative 1/2 is negative 1, plus 1 is the square root of 0, which is 0. So that works. So that's good. So negative 1/2 is good to plug in. If I plug in 0, I get square root of 2 times 0 plus 1. Oh, there's actually the 2 right there. I'm going to get myself 0 plus 1, which is just the square root of 1. So 0 works, and therefore numbers that are bigger than 0 works. And then negative 1, if I do that, 2 times negative 1 plus 1, I get negative 2 plus 1, which is square root of negative 1. And again, I do not want a negative in there. So negative 1 does not work, okay? So the way that I would set up my domain is I got numbers that are going all the way I can plug in numbers that are at negative 1/2, and then all the numbers that are bigger. So eventually I'm going to reach infinity with a parentheses, and then I can plug in negative 1/2. So I'm going to use the bracket there. All right, so I use this bracket to say I can plug in negative 1/2 instead of the parenthesis. All right. Or if you wanted to write it another way, x is, again, greater than, again, it's always going to be x is greater than, because we're wanting the numbers that are bigger than or equal to negative 1/2, because this tells me I can plug in any x value that is bigger than negative 1/2 or 1/2 itself. All right, so again, 2 different ways that you can type in your domain there. All right, now the last one here, I'm not really going to write out very much. So h of x, 1/2 x squared plus 7x minus 2. Now I might write it out here. It's kind of the same as 1/2 x squared times x squared plus 7x minus 2. Now with this one, again, you're still looking for your 2 things. Is it on the bottom of a fraction, or is it underneath the square root? Now for this one, it is none of those, all right? Now technically you might think, well, this x squared is on the bottom, might be on the bottom of the fraction. If it's not written like this, then it is not on the bottom of the fraction. We basically treat it like it's just being multiplied by the whole thing, all right? So for that one right there, it's not on the bottom of a fraction, and it's not underneath the square root sign. So for that one, going back to what I said, if it doesn't have any of those, if it doesn't follow any of those 2 rules, I just have negative infinity to infinity as my domain, all right? So again, no x on the bottom of a fraction, no x on the top of the no x underneath the square root. That is my domain for h of x there, all right? Thank you guys for watching. I will have the second part of 8.3 up later. Thank you.